Today we're going to discover what is meant by exponential growth functions and talk about the basic properties of exponential functions, which perhaps you're familiar with. If not, this will be something new, but nothing too complicated. So the way we're going to do this is by looking at a simple question. You want to put a certain sum of money in the bank. The bank promises that at the end of every year it will increase your balance by 5%. Write a function that will give you the balance after any year. So this is just how any bank works, right? They say, hey, we want your money, we want to hold your money, and in order to give you some incentive to have us hold your money, we're going to give you a certain percentage of the money you give us back every year. So say you put in $100. After the first year, they're going to say, thank you for leaving your $100 in the bank. We're going to give you 5% of that, or $5 extra. So now you'll have $105. And that's why you hear people say, hey, it's important to leave your savings in the bank because you'll keep making money. Now, this is actually a lot bigger than most banks give you, but it'll help us to understand where exponential growth functions come from. So right off the bat, there are a couple things that we want to talk about. First, what do we call this certain amount of money that we're putting in the bank? Let's give it a name. Let's call this sum of money that we're putting in the bank A. We'll just call this A. And we don't know how much it is. We're just going to say it's some value A. It could be 100, could be 1,000, whatever it is. But we just want to leave it as general as possible. And the other thing that we know is that every year the balance increases by 5%. And right off the bat, we probably can't just write a function down. We don't have, right now, it doesn't pop into our head. And so what is a method that we can use to kind of figure out what the function is, what the rule is? I want you to just pause for a second and just think of some things that you could do. What does common sense tell you you should do? Hopefully one of the things you thought of is what happened if you just took it year by year? Sometimes it's really helpful to just play out the first couple of years to see if you notice a pattern. All a function is a rule that happens over and over again. And so if you can figure out what that rule is that keeps happening over and over again, well, you'll know what the function is. So that's the method that we're going to go about using so that we can figure out what the rule is. So let's start with year 0. After 0, maybe I should just say 0 years. After 0 years, if you put in $A into the bank, how much money should you have in the bank now? Pretty simple, right? You're just going to have $A still in the bank. Okay? Nothing too crazy. All right, what about after 1 year? Well, what's the deal? The deal is that if you put some certain amount of money in the bank, then after each year, it's going to increase your balance. The bank's going to increase your balance by 5%. So I want you to try writing this down for yourself. Hopefully, what you saw is that, okay, I'm going to have that $A that I put in, and then they're going to add on to it 5% of that. How do I get 5% of that? Well, I'm going to take 0.05 and multiply it by however much I put in. Right? So if you're thinking about it, here's the original amount, and then after this 1 year, they're going to take 5% of that original and add it on. Okay? And we're actually going to write this, we can simplify this, because we have a common term in each part, right? We could pull out an A. So I can write this as A times 1 plus 0.05. And you'll see why we do this in a second. It always helps to simplify things because it will allow us to more clearly see what's happening. Okay, on your own now, I want you to try and write down how much money you would have in the bank after 2 years. All right, so after 2 years, you're going to have the amount that you had after 1 year. Use a different color. and then you're going to add on another 5% of whatever that amount was. So you're going to have 5% of whatever that amount was. So make sure we understand, this is the amount that we started with after year 1, and then we took 5% of that amount and we're adding it on. So this is the 5% that we're adding on. And now we want to simplify this again, okay? Let's take a look at the two terms we have. What do those two terms have in common? Well, hopefully you notice that there's an A times 1 plus 0.05 here, and there's also an A times 1 plus 0.05 here. So if we were to simplify this, you can pull out an A times plus 0.05. And what we'll end up with is A times, and we can actually write this as 1.05 if you want. Let's do that. And we've pulled it out, and what do we have left on the inside? Well, we have 1 here, right? There's 1A plus 0.05 here, plus how many A times 1.05s are there here? There's 0.05 of them. And to make this even more simple, we can write this as A times 1.05 times 1.05. Well, what's 1.05 times 1.05? If I multiply something by itself, I'm just squaring it. So I have A times 1.05 squared. Notice after 1 year, I have A times 1.05, or I could simplify this to exactly that, A times 1.05, right? This is taking 5% and adding it on. And here I now have A times 1.05 squared. What do you think we will get if we look at year 3? Why don't you go ahead and try that out on your own? So starting with now in year 3, take what we have after year 2 and add on that 0.05 or the 5% of whatever that was, and see if you get what you expect. So hopefully you tried that. If you do, you will find that after 3 years, you're going to have A times 1.05 cubed. Now, you can take this all the way, okay, and we can say, okay, what happens after any number of years? Well, after any number of years, let's say after year T, we'll call year T. Well, after year T, the amount you have in your bank account is going to be A times 1.05 to the T power, where your variable now is the amount that you are putting in your exponent, the number of times that you will multiply 1.05 by itself. Okay? So that function that you're looking for is this function, and this is the exponential growth function. And the reason that we started off writing it as 1 plus 0.05 is to demonstrate that we're adding on a 5%, right? So I want to focus back up here. We start with our original value, and after year 1, we add on to it 0.05 of that value, which is 5%. And we find that if we do this a second year, what we're really going to do is we're going to multiply this situation here, this 1 plus 0.05. We're going to do that again, right? Think about it. We move down here. Well, what do? We do that whole step again, right? We take whatever we started with. In this case, we have A times 1 plus 0.05, and we multiply that piece by the 0.05. So we have a 1 and a 0.05 piece. We pull out the common factor, and we can now simplify to the point where we have just this 1.05 squared. But it's important to note that this 1 here represents the balance at the beginning, and this 0.05 is the added interest. Okay? And so that's where those two numbers come from. All right, that's an introduction. I want you to, if you need to, go back and kind of go back over it again and really make sure you understand it to the best of your possible abilities. All right, so what we just looked at were exponential growth functions, and I want to talk briefly about exponential functions in general. So an exponential function is a function where the independent variable is an exponent, and they come in this form, right? So we saw an example where we had our initial amount, A, times 1.05 to the tth power. So here our independent variable was t, the number of years you'd had it in the bank. 1.05 was your b value in this case, what you're raising to that power, and then you had some coefficient a. Okay? So to think of it, right, a is the initial value. And that should make sense because if you were to plug in 0, either for t or for x up here, anything to the 0th power is 1. So b to the 0 would be 1. So when I plug in 0, I'm just left with a. If I plug in 0 years here, this should make sense because after 0 years, you're still left with a. 1.05 to the 0 is 1, so you'll be left with a. So a is the initial value. And then b, well, b is what we'd like to call the growth factor, or in other words, how much is it growing by every period. In this case, it's growing by 5%. So remember, we have this 100, this 1, which represents the full 100% you're keeping, plus the 0.05 that you're adding on to it. So it's like taking, if you were looking at year 1, it's like taking 105% of your initial value here. Okay? And we'll just call it the growth factor. So when our x value is 0, right, we know that we're at some value a. And then what will happen as the x value increases? So if I start here at a, what will happen as as the x value increases? So as I start multiplying, or I'm sorry, start raising b to a bigger and bigger exponent. Well, let's think about it. Let's take just the number 2. If you rose 2 to the 2nd power, you get 4. What if you raised it to the 100th power? You get some astronomically huge number. It just gets bigger and bigger and bigger. And so we'll look into this more, but the exponential function grows and grows and grows and grows. It grows very quickly. Okay? Grows very, very, very quickly. And so in that way, it will grow. But it's important to note that what types of numbers can you raise to exponents that get bigger? Well, any number greater than 1, right? If you took a number less than 1, say 0.5, and you were to raise it to a higher value, so say you did 0.5 times, or 0.5 to the 100th, and you could try that out. 0.5 to the 100th would get very, very, very small. So this is when b is greater than 1. If b were less than 1, how would it look? Right? Well, it's going to get smaller and smaller and smaller and smaller and smaller and smaller and smaller. Okay, so this would be when b is less than 1. Okay? And of course, if b is 1, how will that look? 1 to any power is 1, so it would just be a and be a constant. And this would be if b is equal to 1. Finish up, I want you to answer this question about you investing $200 in the bank, and they will give you 7% interest every year. How much money will you have in 25 years? And then I want you to write down 1 to 2 questions that you still have that you can bring in for tomorrow.